Okay, picking up where we left off in this problem. So we plotted a couple of key points here. We knew that this wheel at 4 seconds in hit a height of 16. We knew 14 seconds in it hit a height of 16 again. Um, exactly in the middle of those 2 points, it had to hit a minimum, which was going to be at -2. And so just with those key points there, we can kind of put this together. When the last video ended, I was noting we need to be careful. Although it looks like this graph is crossing the midline at 0, it's possible that it's not. And actually, if you think about it a little bit, the period is 10, okay? So that actually suggests that from this point back to this point here is not going to be exactly 2. I think it's going to be 2.5. I think you're going to have 2.5, 2.5, 2.5, and then 2.5, and that'll finish out your period of 10. And so I think it's not quite going to cross the midline at 0. So the point here is because it hits a maximum value at 4, and we know it hits the maximum value there at 4, I'm thinking that writing this as a cosine function instead might make a little bit more sense. Okay, so I think that's what I'm going to use here. So we have all the information. If this is a cosine function, it's been shifted 4 units over because the cosine function normally crosses the y-axis when x is equal to 0. So you can see here I have a phase shift of 4 to the right. So I think at this point we can put all this together and write our equation. All right, so what do we have going on here? Well, we do need to figure out what the b value needs to be. Remember, the period needs to be 10. That's not the b value, that's the period. Okay, the period is 2 pi over b, and that needs to be equal to 10. So we can say the period 10 needs to be equal to 2 pi over b. And we need to find that b multiplier. And so we're going to have to solve this equation. Notice it's not 10 pi, it's just 10. And I can multiply both sides by b here. I'm going to cancel the b. Now I can divide both sides by 10. And what we should see here is that b is going to end up equaling pi over 5. Okay, you're going to have a pi as part of your b value to be able to cancel out uh, the uh, the pi from the period. So pi over 5, that's going to be our b value. So I'm going to make a note of that right there. All right, so let's put our final equation together. By the way, I would encourage you after you write your final equation to actually check your final equation by putting it in a graphing calculator and making sure that you've got everything working out okay. So this is going to end up being y equals, or actually, you know what? They said it's the distance above the water, so we'll call it d of t equals, I'm going to use a t instead of an x variable since they said it's a time equation. The amplitude is 9. Remember, we were doing a cosine function. That b multiplier value is going to be pi over 5. Okay, I can probably write that a little bit better. Let's see if we can do that. Pi over 5. Okay, we're going to have a horizontal shift of 4 to the right. So that would be an x minus 4, or actually in this case, we're using a t minus 4. Okay, and then the whole graph has been shifted up 7 units to get the midline. Okay, so that should be our final equation. And again, for something this complicated, I would highly encourage you to put this in a calculator and make sure you set up a window that's very similar to the window that you had when you set up the original drawing. And also remember that your calculator will force you to have parentheses after the cosine. So this whole thing will need to be in parentheses like that. You're taking the cosine of b times that t minus 4. All right. So I may put together another video where I actually put this in a calculator and make sure it works. But I'm just about out of time here. So I'll see you in that video.